Hello everyone and welcome. Today we're venturing into a story that feels like it was ripped straight from the pages of a science fiction novel, but I assure you it is 100% real. It's a tale of human ingenuity, incredible precision, and our first real step towards becoming guardians of our own planet. We're talking about planetary defense and the mission that proved it's possible, NASA's Double Asteroid Redirection Test, or DART. For decades, Hollywood has thrilled us with stories of brave heroes launching into space to blow up Earth-threatening asteroids. But the reality of planetary defense is far more elegant, more scientific, and frankly, more impressive. It's not about brute force, it's about physics, foresight, and a gentle cosmic nudge. This is the story of how scientists became the unsung heroes, working tirelessly not with explosives, but with mathematics and engineering to protect every single one of us. So why is this so important? The threat of an asteroid impact isn't just theoretical. We live in a cosmic shooting gallery. The Chicxulub impactor, which wiped out the dinosaurs 66 million years ago, is the most famous example, but smaller, significant events happen more frequently. The 2013 Chelyabinsk event in Russia, where a relatively small 20-meter asteroid exploded in the atmosphere, injured over 1,500 people and caused widespread damage. It was a stark reminder that we are vulnerable. In response, space agencies around the world created programs to find, track, and characterize near-Earth objects, or NEOs. But tracking is only half the battle. What do you do if you find one with Earth's name on it? That's where DART comes in. Its objective was audacious and beautifully simple: fly a spacecraft directly into an asteroid to see if we could change its path. The chosen technique is called the kinetic impactor method. Think of it like a game of cosmic billiards. You aren't trying to shatter the cue ball, you're just trying to tap it precisely to alter its trajectory. A tiny change in velocity applied millions of miles away and years before a potential impact can translate into a miss of thousands of miles. The target for this monumental test was carefully selected to be both scientifically valuable and completely safe. NASA chose the Didymos binary system, which consists of a larger asteroid named Didymos, about 780 meters in diameter, and its tiny moonlet, Dimorphos, about 160 meters in diameter, which orbits it. This was the perfect laboratory. Because Dimorphos orbits Didymos, scientists could measure a change in its orbital period with telescopes from Earth. It's much easier to spot a change in a small, quick orbit than to measure the subtle path change of a solo asteroid traveling through the vastness of space. Crucially, the Didymos system's orbit doesn't intersect with Earth's, meaning that no matter what happened during the test, it posed zero threat to our planet. The DART spacecraft itself was a marvel of focused engineering. About the size of a golf cart, it was essentially a smart, high-speed projectile. Its main instrument was Draco, a high-resolution camera that guided it during its final autonomous approach, sending back breathtaking images until the very last second before impact. On September 26, 2022, after a 10-month journey, DART, traveling at a blistering 14,000 miles per hour, slammed head-on into Dimorphos, 7 million miles from home. The world watched, holding its breath. The results were nothing short of spectacular. Scientists had calculated that a successful mission would shorten Dimorphos's 11-hour and 55-minute orbit by at least 73 seconds. They would have been thrilled with 10 minutes, but the data that came back was staggering. DART's impact didn't just shorten the orbit by a few minutes, it altered it by a colossal 32 minutes. This was a monumental success, exceeding all expectations. The impact not only transferred the momentum of the spacecraft, but also created a massive plume of rock and debris which jetted out into space. This plume acted like a rocket engine, giving the asteroid an extra push, a phenomenon called momentum enhancement. This discovery is critical, suggesting that the kinetic impactor technique is even more effective than previously thought. The success of DART has fundamentally changed our relationship with the cosmos. We are no longer passive observers waiting for fate to decide our future. We have demonstrated for the first time in history that we possess the technology and the knowledge to defend ourselves. This mission wasn't the end of the story, but the beginning of a new chapter in planetary defense, a foundation upon which all future strategies will be built. It represents a shift from a reactive to a proactive species capable of shaping its own destiny among the stars. This achievement is a testament to the power of science to solve humanity's greatest challenges, proving that sometimes the greatest heroes are the ones in a lab coat looking at the stars and figuring out how to protect the world below. This mission proves we can be the protectors of our own home, a truly world-changing breakthrough. What other scientific breakthroughs do you believe will fundamentally change our world? Let us know in the comments. Subscribe for more deep dives and see you in the next one.